All right, this video is for Unit 6, Lesson 3 notes. We're going to be dividing these polynomials today. So the first method we're going to use is the box method. So when we multiply using the box method, we would do 2x squared plus x minus 6, and then 2x minus 3, and then we would multiply these pieces out. So this would be 4x cubed, this would be 2x squared, this would be negative 12x, negative 6x squared, negative 3x, positive 18. And remember, your like terms line up in these diagonals. So your final answer, and this is multiplication, we're not dividing yet, negative 4x squared, negative 15x, and then plus 18. To divide, so when we multiply, everything goes on the outside. When we divide, the first piece goes on the inside, okay? So this box here, what we're going to have to do is this x, we would have to split in the middle. I am not a fan of the box method for division. I'm going to show it to you because some of you may get it. So what we do is the 2x squared would go here, and the minus 6 would go here. We don't do this x yet, okay? And then we fill in what we know. We know this is 2x, and we know this is minus 3, okay? So remember, division and multiplication are opposites. So we know we're going to have to multiply this second piece by something to get this first piece, okay? So this is more like a puzzle. So you start with the pieces that you know. 2x times what gives you x squared? Well, that would be an x. 2x times x gives me 2x squared. Now I can start filling in other pieces. X times a negative 3 is a negative 3x, okay? Same with this one. Negative 3 times what would give me a negative 6? Well, that would be a positive 2. And then 2x times 2 would give me a 4x. Now I need that to equal this x. I need this diagonal to equal x. And negative 3x plus 4x does give me a positive x. Okay, so the patterns from the box method, you don't have to write this down, is the diagonals are the like terms. The outsides multiply together to equal the inside. Okay, so we'll practice a little bit with this box method here. The bigger they get, the harder they are. So here we know we're going to have 2 this way. Okay. This one though, we're going to make a bigger box than what we need. Okay. So we know for sure we're going to need 2 rows because we've got 3x minus 2. Okay. Put some spaces in here. Okay, so we know we've got 6x cubed. These are going to be our x squared. These are going to be our x's. Okay, so again, remember our diagonals add up to do these. Those are going to be our x squared. These two are going to be our x's. And then these are going to be our plain old, our constants. I'm just going to use a C for constant there. Okay. So we know x times what gives me x cubed. We know that's going to be an x squared. And then 3 times 2 is the only thing that's going to give me a 6. Okay, 2x squared times negative 2 is going to be a negative 4x squared. And then, let's see here. We're going to need another x squared here. So we've got an x. So we know we're going to have to multiply that by something x. Okay. So if we multiply it as it is, 3x times x gives me 3x squared. 3x squared and negative 4x squared gives me a negative x squared. So this is what I mean by the puzzle, and this is why I do not like this method. Okay. All right. Negative 2 times x is negative 2x. So the other way you can look at it is negative 2x. What do I need to combine that with to make a negative 5x? Well, that would be a negative 3x. How do I make a 3x into a negative 3x? I multiply it by a negative 1. And the negative 2 times negative 1 would give me a positive 2. And so this would be my answer right here. Again, this is not the method that I use. I do not like this method. So I'm going to go ahead on the next page. We're going to do the long division. I just kind of want to see how she does it. All right, we'll go ahead. We'll do this box method one more time. Again, this is just not the method. I don't even teach this to Algebra 1 kids. All right, one thing when we're doing division, we need all the terms in here. So there's no x squared term. So I would have to rewrite this. I would add a 0x squared in there. I just need it as a placeholder. Okay, so here's my box. We know it's going to have 2 rows because it's x minus 4. And we know for sure x to the 4th is going to be here. Okay, so x times what gives me x to the 4th? Well, that's x cubed. So x cubed times negative 4 is negative 4x cubed. I need a negative 3x cubed. Okay, so if I've got negative 4, but I need negative 3, I need a positive x cubed. So I know that's my next term. So x times what gives me x cubed? Well, that's x squared. All right, so negative 4 times x squared is negative 4x squared. This is 0. I need this to be a 0. So that means my like term has to be the opposite, has to be a positive 4x squared. X times what gives you 4x squared? That's a 4x. 4x times negative 4 is a negative 16x. I need a negative 7x though. So negative 16x and a positive 9x are going to give me that negative 7 that I need. So x times 9 gives me 9x. Negative 4 times 9 gives me negative 36. So here's where everything kind of goes off the rails. If I end with a constant, I can't go a step further here. But I need my constant to be a negative 14, not a negative 36. So to make a negative 36 a negative 14, I'm going to have a remainder. And that remainder is going to be 22. 22 plus negative 36 gives me that negative 14. So how I write that, x cubed plus x squared plus 4x plus 9, I would take my remainder, and it's positive, so plus 22, and I would put it over what I divided by. Sorry, that's really fuzzy there. Let me see if I can get it to focus. All right, that's a little bit better. Okay, so that's the box method. Again, not the method that I would choose. So we also have long division. Okay, so long division, I'm not going to get into the algorithm and any of this stuff. It's long division like you were taught in elementary school. What comes first is going to go underneath my bracket. Again, we've got to make sure that we have every term in here. So sometimes we do have to put placeholders. And that's going to be divided by 3x minus 2. All right, all that I look at when I'm dividing is this, the 3x, and then this first term, the 6x cubed. Okay, so 6x cubed, or 3x times what gives me 6x cubed? Well, 3 times 2 gives me 6. And then x times x squared, notice I'm putting it over the x squared term because like terms. X times x squared gives me x cubed. So 3x times 2x squared gives me 6x cubed. Now, I have to multiply this piece out. Negative 2 times 2x squared gives me negative 4x squared. Remember, in regular division, you subtract. We have to subtract this whole piece. Now, remember back from the very first lesson, when we subtract, everybody's sign changes. So we subtract by changing signs. 6x cubed minus 6x cubed cancels. Negative x squared plus 4x squared gives me 3x squared, and everything else gets pulled down. All right, 3x times what gives me x squared? That's a positive x. Then we multiply out. 3x times x is 3x squared. Negative 2 times x is negative 2x. We subtract by changing signs. Please make sure you change those signs. So this cancels. Negative 5x and positive 2x gives me negative 3x. Bring your last piece down. If you notice, it's the same, just with opposite signs. 3x times a negative 1 gives me a negative 3x. Negative 2 times negative 1 gives me a negative 2. Subtract by changing signs. Okay, this cancels, and that's what you want. You want everything to cancel out. Okay. Okay, so for this one, again, there's no x squared. So we would have to add that placeholder in there. X minus 4. X times what gives me x to the 4th? That's x cubed. Multiply out. X times x cubed is x to the 4th. Negative 4 times x cubed is negative 4x cubed. Subtract by changing signs. This cancels. Negative 3x cubed, positive 4x cubed is positive 4x cubed. Everything else gets pulled down. Even that placeholder. Trust me. All right, x times what gives me x cubed? Well, that's an x squared. So x cubed, negative 4x squared. Subtract by changing signs. This cancels. Now I have a positive 4x squared. X times what gives me 4x squared? Well, positive 4x. Negative 4 times 4x is negative 16x. Subtract by changing signs. So this would give me a positive 9x minus 14. X times what gives me 9x? That would be a positive 9. 9x. 9 times negative 4 is a negative 36. Subtract by changing signs. And if you notice, this is what we got down to last time. Here's that 22. So if you have a remainder, if you've written your constant term and you have something left over down here, you just take that remainder and put it over what you're dividing by. Okay, so find a quadratic factor that divides evenly into x cubed plus 8. Show that it divides evenly. So a quadratic factor is going to have 3 pieces. So I'm going to write a quadratic. Ax squared plus bx plus c. That's the factor that we need to divide by. Again, this is going to be what I'm dividing. This would be my first term. So if I'm dividing by this, I know that I'm going to need 3 rows. Okay, something x squared, an x, and a positive 4. We know we've got x cubed, and we know we've got an 8. Okay. Also, this goes back to knowing your pieces, knowing that if I divide a cubic by a quadratic, I'm going to get a linear factor. Okay. All right, so x cubed. I know this has to be an x squared, and I know there's not going to be any coefficient because I can't multiply anything to get a 1 coefficient. Okay. All right, these two are going to have to cancel out. Sorry, I'm looking at the best way to describe this to you. So we know these two are going to have to cancel out, and we know these two are going to have to cancel out. So we know this is going to be an x term. We just don't know what x term. And we know this is going to be a constant. We also know that this is going to be a constant. Okay. So x times x is going to give me an x squared. Again, I just do not like doing these with the box method. It's just not the way that I would choose to do these. So let's skip that one for now. I'm going to come up with a better way to show y'all how to do those. There's a way that you can graph, and it works a lot better. And I think that's the way I'm going to show you. Let me pull up Desmos really quick and show you what I'm talking about by graphing. Here it is. Okay, so x cubed plus 8. Okay, zoom out a little bit here so you can kind of see this quadratic. Right here, this x-intercept, that's a factor. That -2 is a factor. This is how I teach algebra to do these when we talk about factors. So we know we have x equals -2, that's a factor of this. So that means x plus 2 is a factor. So I know this up here is going to be x plus 2. Okay. So 2 times x squared is 2x squared. If I need the opposite, that's a -2x squared, which means this piece has to be a -2x. Okay. 2 times -2x is a -4x. Again, these have to cancel, so I know this box has to be a positive 4x, which means x times a positive 4 gives me a 4x, and 4 times 2 gives me 8. I always go for the linear factors. Find the linear factors and work backwards from there. All right. Synthetic division, I like, but it can be difficult. Okay. You can use any of these methods. If you want to use long division, you can use long division to do these. Okay. Okay. If I have a factor of x plus 1, that means x equals -1. Okay. So I'm going to write a -1. I'm going to write it in a little kind of half box like that. And then I'm going to write the coefficients. Again, I have to have every term, x cubed, x squared, x constant. Just the coefficients. 2, -2, -34, -30. Okay. Leave you a space. First step, bring down the 2. All right. -1 times 2 is a -2. -2 plus -2 is a -4. -1 times -4 is a positive 4. -34 plus 4 is a -30. -1 times -30 is a positive 30. -30 plus 30 is a 0. That's always going to be where your remainder is. So my answer using synthetic division, these are my coefficients. If I start with x cubed here, my answer starts with x squared, and I just work my way down. Again, you can use long division. Synthetic division is a little bit quicker. So x minus 4 means I'm going to have a solution of x equals 4. Coefficient here is a 1, -3. There is no x squared, so I use a 0. -7, -14. Leave you some space. Pull the 1 down. 4 times 4, or no, sorry, should have pulled the 1 down, sorry. 4 times 1 is 4. -3 plus 4 is a positive 1. 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. -7 and 16 combine to make a 9. 4 times 9 is 36. Those combine to make a 22. Again, this is your remainder. Starts with x fourth, so this is going to be x cubed. X cubed. So x cubed plus x squared plus 4x plus 9 plus the remainder 22 over what we divided by. Okay. X plus 3 means I'm going to have a solution of x equals -3. My terms here, x to the 4th, no x cubed, so I use a 0, x squared, x 4. Bring the 1 down. -3 times 1 is -3. 0 plus -3 is -3. -3 times -3 is a 9. -10 plus 9 is a -1. Negative 3 times negative 1 is a positive 3. Negative 2, positive 3 gives me a positive 1. Negative 3 times 1 gives me a negative 3. 4 plus negative 3 gives me a positive 1. That's my remainder. Starts with x fourth, so this is going to be x cubed minus 3x squared. This would be an x, so minus x plus 1, and then the remainder, 1 over x plus 3. Okay, 3x minus 2. If I set that equal to 0 and I solve for x equals 2/3. So be really careful with ones like that. All right, we've got a 6, a negative 1, a negative 5, and a positive 2. Bring the 6 down. 6 times 2/3 is a 4. How I do that so quick? 6 times 2 is 12. 12 divided by 3 is 4. Just fractions. Negative 1 plus 4 is a 3. 2/3 times 3 is a 2. Negative 5 plus 2 is a negative 3. 2/3 times a negative 3 is a negative 2. 2 and negative 2 make a 0. That's my remainder, meaning no remainder. Starts with an x cubed, so this starts with an x squared plus 3x minus 3. All right, last bit of this. Remainder theorem. If a polynomial is divided by a binomial, the remainder obtained is p of a. So, given p of x equals x cubed minus 4x squared minus 7x plus 10 was divided by x minus 2, the remainder can be determined by finding p of 2. Okay, here's what that means. Look for what x equals. So remember, this is the one that we did in the last one. X equaled 2/3. So if I take that 2/3 and I plug it in for every x here. Oh, shoot. 2/3 squared minus 5 times 2/3 plus 2. And I solve this out. Type this in your calculator, right? It equals 0. That's your remainder. And that's what we got. That's what we got as our remainder here. Okay. So this one here, x equals 4. We've done this one before. Swap all the x's out with a 4. So 4 to the 4th minus 3 times 4 to the 3rd minus 7 times 4 minus 14. I'm going to show you the quick way to do this. You could type all of that in your calculator, just like what you've seen me right here. Or on the graphing side, you could type this in. X to the 4th minus 3x cubed minus 7x minus 14. And pull up the table and go to where the table where x is 4. Where x is 4, y is 22. 22 would be your remainder. And again, we know that's correct. We've worked this problem twice now, 3 times now. Okay. So this one, again, x equals negative 2. You could go and you could plug that negative 2 in for all the x's. Or you could create a table for it. And Desmos will do this for you too. Go to where x is negative 2. Remainder is going to be 0. All right, last one. X minus 3 means it's going to be a positive 3. So x cubed plus 4x squared plus 5x plus 2. Pull up the table, go to where x is 3. We get 80. Means our remainder is going to be 80. All right, and then finally, the rational root theorem says that a rational root of a polynomial function is of the form p over q. P is the factors of the last term. Q is the factors of the first term. This is used when determining potential factors of a polynomial or when an unknown factor is needed in order to divide polynomials to solve. So we're going to find all the rational roots here. So this is Q. This one here is P. Okay, so the factors of Q is 1, positive and negative 1, right? Because it's a 1. The factors of 6 are 1 and 6, right? Or 2 and 3. So positive negative 1, positive negative 2, positive negative 3, positive negative 6. The reason I'm putting the negatives in there is because negative 1 times negative 6 gives me a positive 6. So we would divide all of these P factors by the Q factors. Well, if you're dividing by 1, here's my possible roots. If you're dividing by 1, everything on the top stays the same. So it's either positive negative 1, positive negative 2, positive negative 3, positive negative 6. And again, those are just used if you don't know what to divide by. Okay? This one, here's Q. This one is P. The factors of 35 are 1 and 35, and 5 and 7. 5 times 7. Sometimes it helps to write them out that way. Factors of 6 we already know. So we divide the factors of P, positive negative 1, positive negative 5, positive negative 7, positive negative 35, by the factors of Q. We know these are the factors of 6. Positive negative 1, positive negative 2, positive negative 3, positive negative 6. And then we simplify this down. Okay? This is a huge, long list. This is one of those theorems that I do not like. Okay? You have to divide each of these top pieces by each of these bottom pieces. So if we're dividing by 1, our possible roots, I'm just going to do PR for possible roots, would be positive negative 1, positive negative 5, positive negative 7, positive negative 35. Divide everything by 2. So 1 divided by 2 would be a 1/2. 5 divided by 2 would be a 5/2. 7 divided by 2 would be a 7/2. And then 35 divided by 2 would be 35/2. Then you divide by 3. 1 divided by 3 would be a 1/3. 5 divided by 3 would be 5/3. 7 divided by 3 would be 7/3. 35 divided by 3 would be 35/3. Then we divide by 6. 1 divided by 6 would be 1/6. 5 divided by 6 would be 5/6. 7 divided by 6 would be 7/6. And 35 divided by 6. She didn't list that one. Sorry, I'm trying to look to see what she did and why she didn't list that one. It would be 1/35/6 because it doesn't simplify. Sometimes you get ones that duplicate and you wouldn't write those down. All right, so that's it for this set of notes.